In this lecture, we'll discuss about the unit 12, or we can say chapter number 4. We can say chapter number 4, hydrocarbons. Now, let's start it. So, now let's come towards its introduction. So, hydrocarbons are the simplest type of organic compounds. Hydrocarbons are composed entirely of carbon and hydrogens. So, you can say hydrogen atoms, and are widely used as a fuels, diesels, gasolines, natural gas, and liquefied petroleum gas (LPG), and are a common example. So we can say these are common examples of hydrocarbons, as they contain only carbon and hydrogen atoms. Therefore, hydrocarbons are non-polar covalently bonded compounds. तो ये बता रहे कि हाइड्रोकार्बन्स क्या चीज़ है. हाइड्रोकार्बन ये सिंपलेस्ट टाइप ऑफ ऑर्गेनिक कंपाउंड्स है. और हाइड्रोकार्बन्स वो कंपाउंड्स है जो कार्बन और हाइड्रोजन पर मुश्तमिल होता है. इसको हम एज ए फ्यूल यूज़ करते हैं, जैसे कि डीजल है, गैसोलीन है, नेचुरल गैस है और एलपीजी. तो इसको हम एज ए फ्यूल इस्तेमाल कर सकते हैं. तो ये इनकी एग्जांपल्स है, जिस तरह एलपीजी है, डीजल है, गैसोलीन है, पेट्रोल है. सो यू कैन से दैट दीज आर हाइड्रोकार्बन्स, क्योंकि ये सिर्फ कार्बन और हाइड्रोजन पर मुश्तमिल होते हैं. Therefore, hydrocarbons are non-polar, commonly against covalently bonded compounds. तो हाइड्रोकार्बन जो होते हैं वो non-polar होते हैं, तो ये covalently bonded compounds होते हैं. So you can say now scientists classify hydrocarbons naturally as a saturated hydrocarbons and unsaturated hydrocarbons. साइंसदानों ने हाइड्रोकार्बन्स को दो ग्रुप्स में तकसीम किया है. तो इनमें से एक को हम सैचुरेटेड हाइड्रोकार्बन्स कहते हैं और दूसरे को अनसैचुरेटेड हाइड्रोकार्बन्स कहते हैं. तो सैचुरेटेड हाइड्रोकार्बन्स यू कैन से आर कॉल्ड अल्केन्स, एंड अनसैचुरेटेड हाइड्रोकार्बन्स यू कैन से these are alkenes and alkynes. In this unit, you will only study the name, structure, and types of organic compounds of hydrocarbons. तो हाइड्रोकार्बन जो होते हैं वो उनको साइंटिस्ट ने इसको तकसीम किया सैचुरेटेड और अनसैचुरेटेड, यानी सैचुरेटेड हाइड्रोकार्बन्स एंड अनसैचुरेटेड हाइड्रोकार्बन्स. तो ये जो है दो तरह के होते हैं, सैचुरेटेड और अनसैचुरेटेड. सैचुरेटेड हाइड्रोकार्बन जो होते हैं वो मोस्टली ये अल्कीन्स होते हैं, अल्कीन्स कहलाते हैं. और जो अनसैचुरेटेड हाइड्रोकार्बन होते हैं वो अल्कीन्स और अल्काइंस कहलाते हैं. तो नाउ नेक्स्ट वन, द फर्स्ट वन इज यू कैन से दैट अल्केन्स. सो यू कैन से दैट अल्केन्स, व्हाट आर अल्केन्स? Or the alkanes, so you can say alkanes hydrocarbons that has only single bond, also known as saturated hydrocarbons. तो alkanes वो हाइड्रोकार्बन है जिसमें सिर्फ सिंगल बॉन्ड होता है, तो इसलिए हम इसको सैचुरेटेड हाइड्रोकार्बन्स कहते हैं. तो you can say alkanes that don't contain ring have the general formula CnH12+2, where N is the number of carbon atoms. ये तो हम पहले भी डिस्कस कर चुके हैं कि अल्केन्स क्या होते हैं. अल्केन्स वो हाइड्रोकार्बन है जो जिसमें सिंगल बॉन्ड होता है. इसके अलावा इसको हम सैचुरेटेड हाइड्रोकार्बन्स कहते हैं। तो अल्केन्स ये इसमें रिंग नहीं होता है एंड हैव इसका फार्मूला जो होता है ये CnH2n+2। तो ये इसका फार्मूला है और यहाँ पर N stands for number of carbon atoms. Now, alkane you can say in shape of an alkane in the shape of a ring is called the cycloalkanes. alkane अगर उसके जो शेप है रिंग की सूरत में है तो उसको हम साइक्लोअल्केन्स कहेंगे। और इसके अलावा cycloalkanes have the general formula CnH2n. So we can say here a cycloalkanes has formula CnH2n, while that of alkanes has the formula of CnH2n+2. So this is the difference. So now alkanes, we can say the alkanes and cycloalkanes all so we can say in alkanes and cycloalkanes, all the four bonds of carbon atoms are single. तो alkanes जो भी होते हैं यानी कि cycloalkane हो या ओपन चेन हो या यानी इसमें जो बॉन्ड होता है वो सिंगल बॉन्ड होता है। तो देयरफॉर दे आर सैचुरेटेड हाइड्रोकार्बन्स, तो इसलिए हम इनको सैचुरेटेड हाइड्रोकार्बन्स कहते हैं। These compounds are less reactive and also called paraffins. इन कंपाउंड्स को हम ये लेस रिएक्टिव इनको हम पैराफिन कहते हैं। You can say these are also called paraffins. Paraffins, you can say they are saturated. So these compounds are less reactive and are also called paraffins. Para means little and affin means affinity. So you can say alkanes are those compounds which have little affinity. यानी इसकी जो इलेक्ट्रॉन affinity होती है वो यानी उसकी जो affinity होती है वो कम होती है इसकी जो alkanes हैं। you can say alkanes and cycloalkanes form a series of compounds known as a homologous series. So some of their group members and electrons cross and dot structure of the first 5 alkanes are shown in the figure. So alkanes are here represented in the table. So you can say this is a molecular condensed structure and data and cross formula of the first 5 alkanes. So you can say this is a name, this is a molecular formula, and this is a condensed formula. So the first one is, you can say methane. Methane is formula CH4. So you can say methane has a formula CH4, and this is CH4, and this is ethane. The formula C2H6, and you can say that this is CH3CH3. So similarly, you can say that propane has formula C3H8 and condensed formula CH3CH2CH3. So this is the case, you can say. Similarly, butane has formula C4H10 and CH3CH2 CH3. Pentane has formula C5H12 and CH3CH2 CH3. So this is you can say. Now next one is the structure formula of alkanes up to 5 carbons. So this is the structure formula of methane, which has 4 hydrogen and 1 carbon. This is the ethane having you can say 6 hydrogen and 2 carbons, and this is the propane having 3 carbons and you can say 8 hydrogens. So this is the butane having 4 carbons. You can say this is 10 hydrogens, and this is the pentane having 5 carbons and 12 hydrogens, 2, 4, 6, 8, 10 and 12. And this is the electron cross and dot structure of alkanes up to 5 carbon. So this is the methane having you can say the cross and dot structure. So here you can say this is represented by cross and dot. So each carbon has 4 electrons in their outermost shell. So it has the capacity to attach 4 hydrogens by forming 4 covalent bonds. So in the same way, it then has structure of dot and cross. So this is the case in case of ethane. So propane has, you can say, is a 3 carbons in which you can say total of 8 hydrogens are attached here with. So this is the butane having 4 carbons, having 10 hydrogens attached with. This is the pentane having 5 carbons, and you can say 12 hydrogens you can say attached with the 5 carbons. Next one is, you can say, nomenclature of organic compounds. So the naming of organic compounds, so you can say before 1947 was based on the common system. As organic chemistry grew and developed, the scientists formed a common committee called the International Union of Pure and Applied Chemistry, so IUPAC, to establish an international standard of naming compounds to facilitate communications. The function of this committee is to suggest the systematic method of naming the organic compounds. So we can say that IUPAC system of nomenclature is based on the principle. We can say for each different compound should have a different name. This committee formed some rules. These rules for naming alkanes are given below. So we can say that in before 1947 यानी 1947 से पहले जो ऑर्गेनिक कंपाउंड्स थे उनके कॉमन नेम्स थे लेकिन उसके बाद ना फिर जब ऑर्गेनिक केमिस्ट्री तरक्की कर गया तो साइंटिस्ट ने एक कमेटी बना दी जिसको आयुपिक कमेटी यानी इंटरनेशनल यूनियन ऑफ प्योर एंड अप्लाइड केमिस्ट्री आयुपिक की कमेटी बनाई है। तो इस कमेटी का काम क्या था? इस कमेटी का काम था कि यानी जो इंटरनेशनल स्टैंडर्ड के नाम कंपाउंड्स को अलॉट किए जाए ताकि कम्युनिकेशन में आसानी हो। यानी जितने भी ऑर्गेनिक कंपाउंड्स हैं उनको ऐसे स्टैंडर्ड नाम दिए जाए जिसको पूरी दुनिया में उसकी कम्युनिकेशन इजी हो। सो इसके अलावा इस कमेटी का जो काम था, द फंक्शन ऑफ दिस कमेटी इज टू सजेस्ट सिस्टमेटिक मेथड ऑफ नेमिंग द ऑर्गेनिक कंपाउंड्स। तो इसका जो था ना, ये सिस्टमेटिक तरीके से जो ऑर्गेनिक कंपाउंड्स थे उनके नाम सजेस्ट करने थे। और प्रिंसिपल ऑफ सो ईच कंपाउंड यानी हर एक कंपाउंड को इन्होंने अलग अलग नाम अलॉट करने थे। तो इस कमेटी ने कुछ रूल्स बनाए ऑर्गेनिक कंपाउंड्स को नाम देने के लिए, कुछ रूल्स बनाए। उस रूल्स को हम यहाँ पर डिस्कस करेंगे। We are going to discuss these rules here below. So you can say that this is the first rules for alkanes. So you can say this is the first rule. The first rule of the committee was identify the longest continuous chain of carbon atoms having the maximum branches, substituents. These chains are called parent chain. So you can say first यानी जो लॉन्गेस्ट जो कंटिन्यूस चेन होता है कार्बन एटम्स का उसको पहले पहचानना पड़ता है तो उसके मुताबिक फिर यानी जिसमें मैक्सिमम नंबर ऑफ ब्रांचेस होती है जैसे कि ये बताया गया 1 2 3 4 5 6 7 इसमें 7 कार्बन है और ये लॉन्ग चेन है तो इसको हमने आइडेंटिफाई कर दिया और इसकी नंबरिंग भी 1 2 3 4 5 6 7 so similarly you can say that number 2 number the carbons of the parent chain from the end that gives the substituent the lowest number यानी कार्बन एटम की जो नंबरिंग की जाती है वो किस तरह की जाती है यानी नंबर को कार्बन को कैसे देंगे यानी उस एंड से शुरू करेंगे जो नंबरिंग है जिसमें जो सब्स्टिट्यूएंट होता है वो उसके करीब होता है उसकी मतलब जो सब्स्टिट्यूएंट होता है वो लोवेस्ट नंबर जिस को मिल जाता है यानी नंबरिंग इस तरीके से हो कि जिसमें जो सब्स्टिट्यूएंट जिस तरह ये सब्स्टिट्यूएंट है इसको कम से कम नंबर मिले क्योंकि अगर हम यहाँ से अब यहाँ पे क्या किया है 1 2 3 4 5 6 1 2 3 4 5 there are 5 carbon atoms having one substituent which is CH3 so तो हम इसकी जो नंबरिंग करेंगे वो यहाँ से करेंगे 1 इस तरह हुआ है 2 this is 2 and this is 3 carbons and you can see this is a 4 and this is a 5 carbon atoms because the substituent is attached here so at position number 2 so the substituent is attached at position number 2 but if we number from this side we can say 1 2 3 4 so if this one is the 4 and this was the 5 so in this case the substituent will get 4 number 4 so but according to the rules we have read that number the carbons of the parent chain from the end that gives the substituent the lowest number so we can say that number 2 number is the lowest as compared to 4 so we will number the carbon chain from left to right or you can say from this towards this side so you can say that this one will be the 2-methyl pentane because this is the methyl group attached at position number 2 so we can say this is 2-methyl pentane because we have 5 carbons so 5 carbons and all carbons are attached by single bond with each other so we can say this is the alkane family and its IPAC name will be 2-methyl pentane so the next example is this is the chain another chain of carbon atoms so we can say how to number this so we can say that if we number from this side we can say this is a 1 this is 2 we can say this is 2 this is number 3 this is number 4 this is number 5 this is number 6 so here we can say that the first methyl group you can say this methyl group is at position number 3 so this is the position number 3 and this methyl group is attached at position number 4 so if we number from this side from left to right but if we number from left from right to left. So we will see that this is a 1 carbon, 2 carbon, and this is a 3 carbon, and this is a 4 carbons, and this is a 5, and this is you can say 6. So from right to left, we can see that the two methyl groups are attached at one is at position number 3 and the other is at position number 4. So 3 and 4, at 3 and 4 positions, the two methyl groups are attached, but from left to right, we see that the two methyl groups are attached, you can say 1, 2, 3, 3 and 4. So from left to right, the two methyl groups are attached at position number 3 and 4, and also from right to left, the two methyl groups are also attached at position number 3 and 4. So it is on our behalf that we number from left to right and from right to left. In both cases, the positions of the two methyl groups are at 3 and 4. So number 3, the parent name of alkane is derived from the common system to the selected chain. The parent name of the alkane is derived from the common system to the selected chain. So we can say this is a chain of carbon atoms having 5 carbons. So this is a pentane, and this is 7 carbons. So it's a hepta series. So we can say heptane. Number 4, the parent name is placed last and the substituent branch is preceded by the number shown its location on the chain. So this is the substituent. You can say that the parent name is, we can say this is the chain of butane because it has 4 carbon atoms. So we can say that this is a parent name is butane. So we will put the parent name in the last and the substituent branch name in at the start. So we can say that this is the chain of butanes, and this is a substituent, you can say methyl group, which is attached at carbon number 2, in position of carbon number 2. So we can say that first we will name the substituent. You can say is the carbon is at position number 2, so you can say 2, and this is the substituent is a methyl group, so this is a methyl, so 2 methyl, and the chain is of 4 carbon atoms, so and all carbons having a single bond. So this is the butane, so you can say this is the parent name butane. So this one, so you can say this is the 2-methyl butane. This is the 2-methyl butane. Similarly, we can say that this is a chain of 6 carbon atoms again, but here you see that the substituent, we can say methyl is attached to with the at carbon number 2. So you can say this is the 2-methyl again. This is 2, this is a methyl group, so 2-methyl and the chain of 6 carbon atoms, so and all carbons having single bond, so this is hexane. So you can say this is the 2-methyl hexane. So in this case, if we number, here we have numbered the carbon from, we can say from this side, from right to left. But if we number the carbon atoms from left to right, we can see that the substituent is farthest, and that will be farthest from the first carbon. So such as you can say if we number the carbon from left to right, so we can say this is the carbon number 1, this is the carbon number 2, this is the carbon number 3, and this is the carbon number 4, and this is the carbon number 5, and this is the carbon number 6. So we can say, in this case, the methyl group is at the position of carbon number 5. So we can say this is the farthest from the first carbon. So according to the rules, we will number from that side, which is lowest, which will give the substituent the lowest number. So we can say from numbering from left to right, the substituent number is 5. While numbering from right to left, we can say the substituent number, the substituent is methyl, this substituent number is 2. So we can say the 2 is the lowest as compared to 5. So in other words, we can say that 2 is less than 5. So we can say so we will number the chain from left from right to left, and we can say from this side. We can say from this side, from right to left. So because by doing this, the substituent got the lowest number, which is number 2. The next example is, you can say, this is another chain of we will have a chain of 3 carbons. So we can say this is all having similar bond. So this is a propane and having methyl group at position number 2. So in this case, we can number the carbon atoms from any side, because from both sides the methyl group is attached at carbon number 2. So we can number the chain from left or from right, and it depends on our side. So in this case, we can number from any side, because in both cases the substituent, which is a methyl group, this is the substituent, it is got position number 2 from any side. So we can say that this is the 2-methyl propane. यानी हम यहाँ पर चूंकि जो प्रोपेन का जो चेन है, इसमें कार्बन जो है मिथाइल ग्रुप हो, कार्बन नंबर 2 पे फॉल करता है, उसके साथ कार्बन नंबर 2 के साथ अटैच है। तो अगर हम इसको राइट से कार्बन्स की नंबरिंग करें, चेन की नंबरिंग करें या लेफ्ट से करें, तो दोनों हालतों में जो मिथाइल ग्रुप है वो कार्बन नंबर 2 के साथ अटैच है। तो लिहाजा हम नंबरिंग राइट या लेफ्ट दोनों में से किसी भी साइड से कर सकते हैं। देयर इज नो मिस्टेक by numbering the carbons from right or from left, you can say. So next one is, we can say that when 2 or more branches or substituent are present, give each substituent a number corresponding to its location on the longest chain. You can say, तो ये बता रहे कि जब 2 या 2 से ज़्यादा ब्रांचेस या सब्स्टिट्यूएंट्स मौजूद होते हैं किसी कार्बन चेन में, तो यानी जो जितने भी सब्स्टिट्यूएंट अटैच हैं उसको हम नंबर देंगे उसकी लोकेशन की मुनासिबत से जो लॉन्गेस्ट चेन पे मौजूद होता है। जिस तरह ये एग्जांपल है, दिस इज यू कैन से दिस कार्बन, द चेन ऑफ कार्बन एटम्स, so you can say this is 1 2 3 4 5 6, a chain of 6 carbon atoms and all having a single bond. So in this case you can say that this methyl group is nearer to the first carbon, and you can say that this carbon is farthest from this methyl group, and this carbon is near to this methyl group. So we can say that we will number from left to right. We will number the chain from left to right. So we can say this is 1, 2, 3, 4, 5, 6. So if we number from left to right, we can see that the first methyl group is attached. This is the methyl group, and we can say this is attached at carbon number 2, and the second methyl group is attached at carbon number 4, position number 4. So, but if we can say from number, we cannot number from you can say from right to left, because this carbon is farthest from the methyl groups. So this is the we will number the carbon atom from left to right. So in this way, the name of this compound will be 2, 4, because the two methyl groups are at position number 2 and 4. You can say there are two methyl groups. We can say dimethyl. So this is 2,4 dimethyl, and the chain is of 6 carbons. So we can say hexane. So 2,4 dimethyl hexane. Similarly, this is the chain we can say of 1, 2, 3, 4, 5. This is another chain of 6 carbon atoms. But in this case, the methyl groups having 3 methyl groups, which are these ones. You can say this is the first one, this is the second one, and this is the third one. So this carbon is near to the methyl group. So अब ये जो कार्बन है ये मिथाइल ग्रुप के इस मिथाइल ग्रुप के करीब है, तो हम चूंकि ये दूसरा भी इस कार्बन के करीब है, यहाँ पर दो मिथाइल ग्रुप जो है ना इस कार्बन के करीब पड़ते हैं, इस कार्बन के करीब पड़ते हैं। तो ये जो कार्बन है यहाँ ये एक मिथाइल ग्रुप तो करीब है, लेकिन बाकी जो दूसरा है वो इनसे दूर है। तो लिहाजा हम नंबरिंग को क्या करेंगे, राइट से लेफ्ट की तरफ करेंगे, बट नॉट फ्रॉम यू कैन से फ्रॉम लेफ्ट टू राइट. So in this case, this will be the methyl groups are in position number 2, position number 3, and position number 5. So 2, 3, 5. So you can say this is 2, 3, 5 trimethyl. The chain is of 6 carbon, so you can say hexane. So 2, 3, 5 trimethyl hexane will be the name of this organic compound. So so similarly, when branches are present in the same carbon atom, so we can say use the number of that carbon twice. So in this case, we can say that this is the carbon chain. So here are two methyl groups attached at carbon number 2. So we can say at carbon this will be 2, 2 and 2 methyl, and then next methyl we can say this group is attached at position number 5. So we can say this will be 2, 2, 5, and there are 3 methyls, so trimethyl, and this is a chain of 6 carbons, hexane. So you can say this is 2, 2, 5 trimethyl hexane. In this case, if two methyl groups are attached to the same carbon, we will consider that twice. Similarly, you can say this is the chain of 6 carbon atoms. So having three methyl groups, and the two methyl groups are position number 2, and the third methyl group is at position number 4. So you can say this name of the compound will be 2,2,4 trimethyl hexane. So now number 7, if the same substituent occurs more than once, so the location of each point on which substituent occur is given. In addition, the number of times the substituent group occur is indicated by prefix di, tri, tetra, etc. A comma is used to separate the position. ये बता रहे कि अगर मिथाइल ग्रुप है या सब्स्टिट्यूएंट जो है, जिस तरह ये मिथाइल ग्रुप है, दिस इज सब्स्टिट्यूएंट, अगर एक ही कार्बन पर मौजूद है तो हम इसको फिर एक ही सेम डिजिट से रिप्रेजेंट करेंगे ट्वाइस, which is separated by comma. So this is the case. You can say this is a chain of 6 carbon atoms. So having 2 methyl groups and carbon number 2, so you can say this is the 2,2 dimethyl. This is the chain of 6 carbons, so 2,2 dimethyl hexane. Now you can say that this is also the chain of 6 carbon atoms having 2 methyl groups at position number 2 and 1 methyl at position number, we can say 4. So this is 2,2,4 trimethyl hexane. Number 8. When 2 or more branches substituents are not identical, then they are arranged alphabetically, such as ethyl before methyl. अगर जो सब्स्टिट्यूएंट आइडेंटिकल नहीं है तो उसमें उसको अल्फाबेटिकली अरेंज करना पड़ता है, जैसे कि इथाइल और मिथाइल अगर दो ग्रुप लगे, you can say if we have two substituents, one is methyl which is CH3 and the other is we can say the ethyl which is CH3 and CH2. So this is the ethyl group and this is the methyl group. So methyl is, so you can say, start from the letter M and ethyl start from letter E. So we know that E comes first and M comes last. I can say that M comes after E or E comes before M. So we will first mention the substituent ethyl because in alphabet E comes first. So if you consider this example, you can say that this is the example of carbon number, we can say has six carbon atoms, 1, 2, 3, 4, 5, 6, and we have two groups, two substituents, one is methyl and other is ethyl. So we can say this one is a methyl group and this one is the ethyl group. So we will first mention the ethyl because E comes first in alphabet. So in this way, this compound will have a name 3-ethyl because ethyl is at position number 3 and the methyl is at position number 4. So we can say this is methyl at position number 4. So 3-methyl, 4-methyl, hexane is the chain of hexane, 6 carbon atoms. So 3-ethyl, 4-methyl, hexane. So this is, you can say, another chain of 6 carbon atoms, which is a 1. So 1, 2, 3, 4, 5, 6. So here we see that the methyl group is attached at position number 2 and the ethyl group is attached at position number 3. So we can say ethyl come first. So 3-ethyl, 2-methyl, hexane. So this is the naming of organic compounds. At number 9, you can say that when there are we can say that when there are two chains of equal length, number the carbons, choose the one where the greater number of branches substitute. So you can say अगर हमारे पास एक कार्बन चेन है उसमें काफ़ी सारी ब्रांचेस हैं तो जो लंबा ब्रांच होता है उसको हमें पहले सेलेक्ट करना है जो लेंथ यानी जिसकी लेंथ ज़्यादा होती है मिसाल के तौर पर ये हमारे पास चेन है तो इसमें यानी वो चेन सेलेक्ट करना है जिसमें ब्रांचेस ज़्यादा होती है ब्रांचेस ज़्यादा होगी तो यहाँ पर अगर हम सेलेक्ट करते हैं तो ये जो है ना ये मिथाइल ग्रुप है इनसे दिस इज द मिथाइल ग्रुप एंड दिस इज आल्सो द मिथाइल ग्रुप्स सो वी कैन से दैट 1 2 3 we can say if we start from here this is the nearest to 1 1 2 3 4 5 6 7 8 this is the chain of 8 carbons and if we start from here we can say the remaining are the shortest chains so we will start from here because the methyl groups are attached nearly attached to this carbon the name of this compound will be 3-ethyl 2,4,5 trimethyl octane. Octane because it's a chain of 8 carbons. So at position number 3, we see that at position number 3 is attached ethyl group. At position number 3 is the ethyl group, while that of at 2, 4, 5, there are methyl groups. 2, 4, 5. This is the methyl group. Like I said, this is the ethyl group CH2 and CH3. This can be written such as. So this is the ethyl group, and at position number 3, this is the ethyl group, and 2, 4, 5. This is the 2 carbon, and this is the 4 carbons, and this is the 5 carbons. So at this position, the methyl groups, these are 2 methyl groups, and this is the methyl group. So 3 methyl groups are in position number 2, 4, and 5. So you can say this is 3-ethyl 2,4,5 trimethyl. Now let's come towards its preparation of alkanes. So how alkanes are prepared? So we can say that alkanes and cycloalkanes are saturated hydrocarbons. The method of preparations and chemical properties are similar. This can be prepared by addition reaction from alkenes and alkynes. So we can say and by reduction reaction from alkyl halide. So the first one is addition reactions. So you can say the reactions in which we can say an atom or group of atoms are bonded to compounds that has a double or triple bond is called an addition reaction. यानी वो रिएक्शन जिसमें हम एटम और ग्रुप ऑफ एटम्स को ऐड करते हैं किसी कंपाउंड में और उस कंपाउंड में डबल या ट्रिपल बॉन्ड होता है तो अगर हम किसी कंपाउंड में जिसमें डबल या ट्रिपल बॉन्ड हो उसमें हाइड्रोजन यानी एटम और ग्रुप ऑफ एटम्स को ऐड करें तो उसको हम कहते हैं एडिशन कैन से एडिशन रिएक्शंस सो अनसैचुरेटेड compounds alkenes and alkynes are associated with addition reactions. तो जो addition reactions होते हैं वो alkenes और alkynes में मुमकिन होते हैं. So you can say that addition reactions are possible in case of alkenes and alkynes. So because alkanes because alkane is saturated having a single bond, so no addition is possible. In case of compounds containing single bonds, you can say alkanes, while the compounds having a double or triple bonds, because these are unsaturated compounds, so addition of more atoms is possible to these compounds. Because so like this, you can say this is the carbon double bond. So this is alkene and this is alkyne having a triple bond. So addition of atoms, addition of an atom or group of atoms is possible in this case. Now, the first you can say in addition reaction, the first one is hydrogenation of alkenes and alkynes. So hydrogenations of alkenes and alkynes. So you can say hydrogenations means addition of hydrogen. Hydrogenation का क्या मतलब है? अगर हम हाइड्रोजन को ऐड करेंगे तो उसको क्या कहेंगे? हाइड्रोजनेशन रिएक्शन. तो यानी अल्कीन्स और अल्काइन्स, यानी अगर हम अल्कीन या अल्काइन में हाइड्रोजन को ऐड करेंगे तो उसको हम कहते हैं हाइड्रोजनेशन of alkenes or alkynes. So because this you can say this is the alkene, you can add hydrogen atom to alkene and alkyne. This is alkyne. So we can add hydrogen to alkene alkynes, and the addition of hydrogen to alkene or alkynes is called hydrogenation. So in hydrogenation reactions, the unsaturated hydrocarbons, alkenes or alkynes, are converted into saturated hydrocarbons or we can say alkenes. यानी कि जब हम हाइड्रोजन ऐड करते हैं अल्कीन या अल्काइन में, तो उसके नतीजे में हमारे पास अल्केन हमारे वजूद में आते हैं. यानी कि एडिशन ऑफ हाइड्रोजन टू अल्कीन और अल्काइंस results in the formation of alkanes, which is a saturated compound. So you can say the first compound is in the form of unsaturated stage in case of alkene and alkynes, and when hydrogen is added to these compounds, the compounds become saturated because the double bond or triple bond is converted into single bond. So this is called hydrogenation of alkenes or alkynes. So we can say this reaction takes place in the presence of nickel as a catalyst at 250 and 300 degrees Celsius. So we can say temperature are in presence of platinum as a catalyst at room temperature. यहाँ पर बताया गया कि ये जो रिएक्शंस हैं, यानी कि अल्कीन और अल्काइन में हाइड्रोजन को कैसे ऐड करेंगे. हाइड्रोजन को अगर अल्कीन या अल्काइन में हम ऐड करेंगे, यानी अगर हम हाइड्रोजनेशन को इनिशिएट करेंगे तो कैसे करेंगे उसको हम अगर रूम टेम्परेचर पे करना चाहें तो हम प्लेटिनम को एज ए कैटलिस्ट यूज़ करेंगे, और अगर हम प्लेटिनम हमारे पास नहीं है, यूज़ नहीं करते, तो हम फिर क्या कैटलिस्ट को करेंगे, कौन सा कैटलिस्ट इस्तेमाल करेंगे? निकल. So nickel will be used as a catalyst, but the temperature will be from 250 to 300 Celsius. While in case of platinum, the temperature is nothing but only the room temperature. So in this case, the reactions of hydrogenation is possible. So the next one is hydrogenation of this is the examples given hydrogenation of alkenes. So how the reaction takes place, these are examples are given. So the first one is, we can say, this is the hydrogenation of alkenes. Alkenes are hydrogenated to, we can say hydrogenated to alkanes in the presence of nickel catalyst at 250 to 300 Celsius temperature. So this is the reactions given. So you can see this is the alkene, ethene. We can say this having a double bond, one double bond, CH2 and CH2. This is the double bond of alkene. I can say this is ethene. So this is the hydrogen, H2 you can say. So if we add a hydrogen to alkene, this is the addition of hydrogen. So in the presence of a nickel catalyst, and we heat the reactions from 250 to 300 Celsius, we can say that we will we will get ethane. So in this case, the double bond is converted into, so this is the, you can say alkene, and this alkene, the double bond is converted into single bond, and from ethene we convert the ethene into ethane. Set temperature this, and this is the catalyst of nickel. So we can say, in simple we can say that this double bond in case of alkene will be converted into single bond, and we will get ethane. So this is the, you can say, this is the ethene. So in case of hydrogenations, we will get this one, CHO3 and CHO3. So this is the hydrogenation reaction. Now next one is, this is the hydrogenation of alkene. Now next one is the hydrogenation of alkyne. So we know that alkyne has triple bond. So if we want to convert the alkyne into alkanes, or we can say hydrogenation of alkynes, so what will happen? Alkynes are hydrogenated to alkanes in the presence of nickel as a catalyst at 250 to 300 Celsius temperature. You can say in the first step, and in the second step, the alkene is further hydrogenated to alkane. So you can say that hydrogenation of alkynes takes place in two stages. In the first stage, alkynes are converted into alkenes because the triple bond is changed into double bond, and in the second phase, the double bond is converted into single bond. Or you can say that the alkene are converted into alkanes. So in the first stage, alkynes are converted into alkenes, and in the second stage, alkenes are converted into alkanes. So this is the hydrogenation of alkynes, which takes place in two stages. This is the example given below. So you can say this is the ethyne CH having one triple bond. So we can say that this is the hydrogenations, addition of hydrogens in the presence of nickel catalyst at 250 to 300 Celsius. So you can say this ethyne is converted into ethene. The first stage, this is the first stage. You can say in this first stage, this is the first step in which this ethyne having triple bond, this is converted into ethene having double bond. And we can say in the second step, you can say, so this is the second step in which we can say that the alkenes are converted into alkanes. So we can say this is the ethene, I can say alkenes, and this is again hydrogenated at this temperature in the presence of nickel catalyst to ethane. This is the reduction of alkyl halides. So reductions means addition of nascent hydrogens. It is removal of halogens such as fluorine, chlorine, bromine, iodine with the addition of hydrogen. So you can say these reactions occur in the presence of zinc, dust and hydrochloric acid. Methyl iodide gives methane and hydrogen iodide on reductions. So you can say this is the reduction of alkyl halide. So you can say this is तो ये बता रहे कि रिडक्शन जो है इसका मतलब ये होता है कि एडिशन ऑफ नेसेंट हाइड्रोजन, यानी एडिशन ऑफ जो नेसेंट हाइड्रोजन है, यानी जो सिंगल हाइड्रोजन है, इसको इट इज़ द रिमूवल ऑफ हेलोजेंस यानी हेलो अल्काइल हैलाइड, रिडक्शन ऑफ अल्काइल हैलाइड यानी किसी जो कंपाउंड से हैलाइड को हटा के उसमें हाइड्रोजन ऐड करना, यानी उसको हम कहते हैं रिडक्शन ऑफ अल्काइल हैलाइड। सो यहाँ पर यानी कि अगर हम एक हमारे पास कंपाउंड है तो उसमें जो हैलाइड है इन द फॉर्म ऑफ क्लोराइड, क्लोरीन, ब्रोमीन, आई कैन से आयोडीन, so the removal of this halide by the addition of hydrogens, so you can say this is the reduction of alkyl halide. So this is the example. Rx is can say alkyl halide. So the addition of 2HO in the presence of zinc and HCl will gives you can say RH, so HX. So you can say by the addition of HCl this X is removed by H. This X is removed by H, so we can say the HX is formed and RH is formed. So hydrogen has replaced this halide. This hydrogen has replaced the halide. So the example is methyl iodide. So if we have methyl iodide, this is CH3I. So if we add 2H in the presence of zinc and HCl, so we can say that hydrogen will replace the iodide. So this one will be formed, HI will be formed, and the hydrogen will replace the iodide, which will form CH3H, or you can say CH4, methane. So this is the reduction of alkyl halide. So similarly, ethyl bromide on reduction gives ethane and hydrogen bromide. So this is the ethyl bromide. By the addition of hydrogen in the presence of zinc and HCl, it produces ethyl, and hydrogen will be added, and the bromine will be replaced by the we can say by hydrogen, and HBr will form, hydrogen bromide will form, and ethyl, you can say ethane. This is the CH3, CH2H, or you can say that CH3, CH3. So this will be formed. So ethane will be formed. Now physical properties of alkanes. The first four alkanes members, you can say methane, ethane, propane, and butane are gases. पहले जो होती है जो अल्केन्स होते हैं, जो 4 मेंबर है, तो उसमें यानी कि मीथेन है, जिससे मीथेन है, और इथेन है, प्रोपेन है, और ब्यूटेन, ये सारी गैसेस होती है। तो नेक्स्ट जो 13 मेंबर्स है वो कलरलेस होते हैं, लिक्विड्स होते हैं, जबकि 13 से ऊपर जो होते हैं वो सॉलिड्स होते हैं। तो अल्केन्स की जो फैमिली है उसमें जो पहले 4 मेंबर्स होते हैं यानी कि मीथेन, इथेन, प्रोपेन और ब्यूटेन, ये गैसेस होती है। जो नेक्स्ट फ्रॉम 5 to 13 दीज आर कलरलेस लिक्विड्स। ये जो 5 से 13 तक होते हैं ये लिक्विड होते हैं कलरलेस, और 13 से जो ऊपर होते हैं वो सॉलिड्स होते हैं। दे आर नॉन पोलर। अल्केन्स क्या होते हैं? नॉन पोलर होते हैं। सो दे आर इनसॉल्युबल इन वाटर, क्योंकि वाटर पोलर है और ये जो ऑर्गेनिक कंपाउंड्स है ये नॉन पोलर है, तो लिहाजा ये पानी में हल नहीं होते, बल्कि ये हल होते हैं नॉन पोलर ऑर्गेनिक सॉल्वेंट्स में, जैसे कि बेंजीन है, ईथर है और एसीटोन है। तो ये यानी कि बेंजीन, ईथर और एसीटोन, इनमें ये हल होते हैं because these are non-polar and acetone, benzene and ether are also non-polar. So we can say uh, number third is they have low melting and boiling points. Alkanes जो होते हैं उनकी melting और boiling points कम होती है. So the melting and boiling points of alkanes increases regularly in the series with the increase in molecular size. यानी alkanes की जो boiling point है वो बढ़ती है मुसलसल अगर हम उसकी मॉलिक्यूलर साइज को बढ़ाना शुरू कर दें तो मॉलिक्यूलर साइज बढ़ने के साथ साथ जो अल्केन्स होते हैं उनकी जो मेल्टिंग पॉइंट है और भी वो बॉइलिंग पॉइंट है वो भी बढ़ जाता है. द नेक्स्ट वन इज से द डेंसिटी ऑफ अल्केन्स इंक्रीजेस रेगुलरली इन द सीरीज विद इंक्रीज इन मॉलिक्यूलर मास. अगर हम मॉलिक्यूलर मास को बढ़ाएंगे अल्केन्स की तो इसकी डेंसिटी भी बढ़ जाती है. इसी तरह alkanes become more viscous as their molecular size increases. अगर हम molecular size बढ़ाना शुरू कर दें तो alkane जो है ना वो ज़्यादा viscous हो जाएंगे. So alkanes are flammable. ये आग पकड़ते हैं. Alkanes as the size of alkanes molecules increases, the percentage of carbon in the alkene molecule also increases. साइज साइज अल्किल मॉलिक्यूल का जब साइज बढ़ता है तो परसेंटेज ऑफ कार्बन जो है अल्किल में बढ़ जाती है जिसके नतीजे में अल्केन जो है लेस फ्लेमेबल हो जाते हैं यानी कि कम आग पकड़ते हैं यानी लेस फ्लेमेबल हो जाते हैं. तो जैसे ही उसमें कार्बन इंक्रीज होती है उसमें अल्केन्स में तो ये लेस फ्लेमेबल की तरफ जाते हैं और वैसे ये फ्लेमेबल होते हैं. So we can say that the next one is the important reactions of alkanes and chemical properties. So we can say alkanes are saturated hydrocarbons consist of only carbon-carbon single bonds and carbon-hydrogen bonds. तो अल्केन जो होते हैं ये सैचुरेटेड हाइड्रोकार्बन्स हैं जो कार्बन कार्बन बॉन्ड्स और कार्बन हाइड्रोजन बॉन्ड्स पर मुश्तमिल होते हैं. तो दिस बॉन्ड्स आर स्ट्रांग एंड आर डिफिकल्ट टू ब्रेक. अल्केन्स में जो बॉन्ड होते हैं वो स्ट्रांग होते हैं और इसको हम आसानी से तोड़ नहीं सकते. तो दस कैन से अल्केन्स आर जनरली अनरिएक्टिव जिसकी वजह से अल्केन्स जो है ना वो कम रिएक्टिव होते हैं. तो इम्पोर्टेंट रिएक्शंस ऑफ अल्केन्स फॉलोइंग. सो नंबर फर्स्ट वन इज हेलोजिनेशंस. अल्केन्स आर सैचुरेटेड हाइड्रोकार्बन्स सो दे मोस्टली अंडरगो सब्स्टिट्यूशन रिएक्शंस. अल्केन जो होते हैं वो सैचुरेटेड हाइड्रोकार्बन्स हैं और इसमें मोस्टली सब्स्टिट्यूशन रिएक्शन होती है. द सब्स्टिट्यूशन ऑफ हाइड्रोजन बाय हेलोजन सच एज क्लोरीन एंड ब्रोमीन in alkane is called halogenations. तो सब्स्टिट्यूशन ऑफ हाइड्रोजन की जो रिमूवल है हेलोजेंस के ज़रिए से जैसे कि क्लोरीन है ब्रोमीन है तो उसको हम कहते हैं हेलोजिनेशन. Alkanes react with halogens in the presence of ultraviolet light. Alkanes जो है halogens के साथ react करते हैं ultraviolet light की मौजूदगी में and produces alkyl halide and hydrogen halide. For example, methane reacts with chlorine, chlorine. You can say in diffuse sunlight and produces methyl chloride. तो यहाँ पर मीथेन जो है वो क्लोरीन के साथ रिएक्शन करके इन द प्रेजेंस ऑफ यूवी लाइट मिथाइल क्लोराइड बनाता है. जैसे ये मीथेन है तो ये क्लोरीन के साथ रिएक्शन करके in the presence of UV light produce methyl chloride and HCl. So this is methyl chloride and which is also called chloromethane. So now in excess of chlorine this reaction does not stop at this stage. In a series of reactions, in each step, one hydrogen atom is replaced by a chlorine atom, so that all the three hydrogen atoms are replaced by the chlorine atoms one by one to give di-tri and tetrachloromethane represented by. So we can say this is a step-by-step reaction. This is the methyl chloride. So we can say methyl chloride with chlorine, this is UV light, produce methylene chloride. So HCl will be formed, so you can say dichloromethane. And the dichloromethane or methylene chloride again react with CCl2, Cl2, and the presence of UV light to produce chloroform. So we can say CHCl3, or you can say this chloroform and HCl, and the trichloromethane, I can say the chloroform, the trichloromethane or chloroform again react with the chlorine in the sunlight to produce carbon tetrachloride. Carbon, we can say tetrachloride, or it is also called tetrachloromethane. The next one is combustion. So combustion reaction is a class of chemical reactions which is commonly referred as burning. तो combustion को उर्फ़ आम में burning कहते हैं. Alkanes की combustion कैसे होती है? Alkanes burns completely in the presence of oxygen to produce a lot of heat, carbon dioxide and water. जो alkanes होते हैं वो उसकी combustion यानी अगर उसकी excess of oxygen यानी ऑक्सीजन की मौजूदगी में उसकी combustion होती है, तो जिसके नतीजे में हीट प्रोड्यूस होती है, कार्बन डाइऑक्साइड और वाटर. तो ये इसको हम कहते हैं combustion ऑफ alkanes. जैसे कि एग्जांपल है, ये एक alkane है मीथेन. तो in the presence of oxygen CO2, I can say it produces CO2, H2 and heat. So this reaction is highly exothermic, and due to this alkanes are used as a fuel. So exothermic means that we can say this reaction produces heat. So we can say that this reaction is highly exothermic because it produces heat. So you can say in a limited supply of oxygen, अगर हम कम सप्लाई ऑक्सीजन उसको प्रोवाइड करें इस रिएक्शंस को, तो इनकम्प्लीट कंबशन ऑफ अल्केन्स टेक्स प्लेस. तो अगर ऑक्सीजन रिएक्शंस के लिए पूरा अवेलेबल ना हो तो इनकम्प्लीट कंबशन होती है अल्केन्स की, और उसके नतीजे में पॉइजनस गैस कार्बन मोनोऑक्साइड बनता है, वाटर और अनबर्न कार्बन बनता है. कार्बन मोनोऑक्साइड इज अ पॉइजनस गैस विच क्रिएट्स सफोकेशंस एंड कॉजेस डेथ. तो ये अल्केन्स है मीथेन. अगर इनसफिशिएंट ऑक्सीजन है तो इनकम्प्लीट कंबशन होती है और उसके नतीजे में कार्बन मोनोऑक्साइड, वाटर और अनबर्न कार्बन बनता है. तो ये बताते हैं कि ये जो कार्बन मोनोऑक्साइड है ये खतरनाक गैस है, और आई कैन से कार्बन मोनोऑक्साइड इज पॉइजनस गैस है which creates suffocations and causes death. तो इसके मौजूदगी में सांस की रुकावट का बायस बनती है और इससे डेथ भी हो सकती है. We can say that the next one, or you can say these are alkenes. and I think we will discuss these alkenes in the next video. So next video we will discuss the alkenes. So thanks for watching.